should not see the innocence is killed. Not written, certainly not shown, but eventually it's meant to be. Covered up, gets known.
And this is your guys. All right, everybody. We're going to go ahead and get started for tonight. It's great to have such a crowded atmosphere here in San Francisco. But if we could go ahead and quiet down, we're going to get started for this evening. Welcome to Meteor Night. My name is Nick Coe. I'm your MC for the evening, and I work on the community team here at Meteor Development Group. We've got an absolutely superb lineup of talks for you this evening. Each of our featured speakers tonight is actually an employee of Meteor Development Group, and they've got some interesting insights to share with you. Before we get started, let me just take a moment to do a bit of housekeeping. We've got a special offer for those of you who are here in person or watching via our live stream. You may have seen that MDG recently announced One Galaxy for Everybody, which delivers reliable, pay-as-you-go cloud hosting with features for simplifying DevOps for apps at any scale. Tonight we're offering a $50 Galaxy credit for the first 25 people who deploy by April 15th using the code MeteorNight316. That's MeteorNight316. So go ahead and get deploying. If you're joining online, you can click live to sync up with the live stream. That makes a lot of sense. You can submit questions for our speakers by tweeting them using hashtag MeteorNight. I'll keep an eye on the hashtag and ask any questions that you've got if you couldn't make it to San Francisco the evening. But please keep in mind that there's about a 20-second lag on the video, so please ask questions as they come up rather than when the question segment starts. That applies to just the online people, not those of you who are in attendance here tonight. Without further ado, let's get started with our featured talks. Our first featured talk tonight is from Dominic Nguyen and Zhenya Savchenko. Dominic is a product designer who creates developer experiences for cloud deployment, authentication, and package management. Before Meteor, he co-founded and led design at Percolate Studio, a software agency that helps businesses create real-time user experiences. Zhenya is one of the engineers who helped us build Galaxy. Tonight, Dom and Zhenya will be telling us about building beautiful interfaces. So, ladies and gentlemen, please welcome Dom and Zhenya.
Hey guys, thank you guys, first of all, so much for being here and watching these talks and joining us here today. So how many people here have heard of Galaxy, aside from what Nick just mentioned? That's like, that's a lot of you. How many people here have used Galaxy? All right, that's a couple of you. So for those of you who don't know anything about Galaxy, it's a cloud hosting service for Meteor. It's an all-in-one DevOps solution, so developers can work on their apps instead of getting sidetracked by ops. Today, we're going to show you how the app team builds beautiful interfaces faster. We'll be using the recently launched Galaxy as our case study. So components, they probably make you think reusable, modular, and predictable. But how do you build components at scale? When an app is small, UI components are manageable. But when your app is large, you're faced with two challenges. The first challenge is that you have a lot of components. And the second is that they become more complex. Today, we're going to show you how we solve these problems when we built Galaxy. My name is Dominic. I'm a product designer here at Meteor. I work with Tim and Zhenya, who are the front-end engineers behind Galaxy. Tim can't be here in person, but he'll make a cameo later in the presentation. Have you ever encountered this challenge? Build a rich UI fast, minimize technical debt, and be ready to serve thousands of customers at launch? Of course you have. This is 99% of the project briefs. And with Galaxy, we certainly felt these same challenges. Galaxy launched in October 2015, about 6 months ago. We started building the user experience in August, about 2 months before release. It is now used by thousands of paying customers, some of which are in this very room. We created a robust UI that handles the many edge cases endemic in a distributed system, a UI that we constantly evolve. And we couldn't have done it without a tool called the Chromatic Component Explorer.
So to understand what a component is, we should probably rewind a little bit. What you're seeing in front of you is the internet as it was in the 90s when it first came out. State was managed almost entirely on the server, which means we had to make round trips to the server every time we interact. When we built apps, we thought in monolithic pages and layouts. As the web grew, it started to become more dynamic. User-generated content increased the scale and complexity of what we have to build. More and more of our UI code became dependent on data, and that data is often personalized to the individual. And so we moved into a world of partials. Partials was the first way we thought about modularizing chunks of layout into reusable pieces, right? It allows us to separate data from layout. Today, we want continuity in our user experience. We want systems to react instantly to user input. And to do this, we recognize that components have to start managing client-side state. So in summary, we've evolved the web through these kind of three phases. And as the interactivity filled the client, we started to formalize how we understand the breakup of our code. So today, we think in components.
A component can be used as interchangeably as a Lego piece. In thinking about modern apps as modular systems, it becomes much easier to build the high-value features our users want. Just like a Lego piece can be used to build a Lego castle or a Lego spaceship, a component can be used by any number of consumer, line of business, or enterprise apps. So how might one go about building apps? Let's take it.
I have a question. When you're rendering the state for the component, is it renders the whole component or just like part of the component where actually the change happens?
If we could actually hold in-person questions until after the presentation, that'd be great. Thank you.
We'll be sure to answer that later. So how might one go about building apps? Let's take a typical organization. Its goal is to build and sell something people want. To be more efficient, organizations often divide themselves into teams filled with specialists, represented here by product, design, and engineering. This allows each member to be more efficient and leads to a higher quality product. Building an app might look something like this. Every member specializes and contributes their skills on down the line to build the finished product. If we wanted to optimize the product assembly, we'd probably parallelize the line so that it looks something like this. Each team would build pieces of a product, components, which would then be combined to yield the product, the finished product. However, even with components, it often ends up looking something like this. A tangled mess of dependencies, and despite everyone's best intentions, components end up too intercoupled. And that's a problem. So what should interfaces be? Let's start by identifying the characteristics of great app interfaces. They allow for more feature development and less minutia. They're well documented. They're robust. They're consistent. Summed up in 3 magical words, they're fast, they're cheap, and they're beautiful. We can solve for fast by breaking out apps into individual pieces and working on those pieces in parallel. Separating UI from real data means that engineers and designers aren't blocked on each other. We can solve for cheap by creating a way for a team to discover and reuse components. It's not enough just to build components. You've wasted your resources and time if folks have to reinvent the wheel every single project and every single feature. Finally, we can solve for beautiful by creating quality interfaces. We need to create systems where we can ensure the reliability of those interfaces. Isolation and clear definition of state makes it easy to develop great components without fearing regressions. We have a solution for fast and beautiful. Fast and beautiful interfaces can be achieved by adopting a strict process. We call ours Style Guide First, and here's what it looks like. The first step is to divide your UI into the smallest possible units and agree on a shared terminology. App after app, one of the hardest parts of a project for me, and likely for you as well, is naming. Just naming things. I've heard this from my colleagues time and time again, Zhenya and Zultan and the rest of the folks here. Naming is impossible. If a team can standardize first around the names of the smallest components, it expedites the build-out process. Second, ensure that you start building components from smallest to largest. I can't stress this enough, smallest to largest. Take the most basic units of your UI, the buttons, the inputs, the menus, and then build out to forms and sections and sidebars. Ensuring components work first in isolation of the real app means that you can build things that are tolerant to the unexpected state changes in a production application. And finally, once you've built out your vocabulary of components, it becomes trivial to assemble them around business logic. This methodology prevents context switching on two levels. There's no context switching when building individual components because we force feature isolation. And then there's no context switching at the high level between the phases of building components and assembling those components. They're separate. Adopting a style guide first process, or something similar, allows the team to work in parallel without clobbering each other. It helped a small team like ours build a big app in no time at all. But what about reducing the cost of development? Building beautiful interfaces is cheap. The key to cost reduction over time is reuse. If you build components in isolation, they're guaranteed to be reusable. And if you organize those components, you'll never have to reinvent the wheel.
Chromatic was built to help our team explore and consume components. It's designed to be the component library for the app you're building. Instead of searching through source code for the thing you're looking for, Chromatic helps engineers discover, visualize, and simulate all the component states. Without too much ado, I will have our Australian counterpart, Tim, walk you through what Chromatic looks like.
Once you've added the Chromatic package to an app, you can view the Component Explorer by navigating to /style guide in your browser. The style guide route is added automatically, but since Chromatic is a debug-only package, this route won't exist when you build for production. Using the sidebar on the left, you can quickly explore all of your components from one place or search for something specific. As you can see, we have fully embraced the componentized UI in Galaxy, as this list spans the many screens and features we've built. For example, this component is used to show custom messages within Galaxy. As you can see on the left-hand side, the component exposes 3 different styles, or specs. Each spec provides different settings and data to the component, resulting in a different behavior or look and feel. Now, working on isolated components is great, but we also want to simulate how they'd appear in a real layout. Chromatic comes with some tools to help you test different layouts, such as changes to viewport size and background color. You can easily change the viewport size from mobile to tablet to desktop, and changing the canvas color can help you visualize how the component will look when paired with light or dark backgrounds. Well, that was a fairly simple component, but how about something more complex? Let's visit the Galaxy progress bar. This component presents the rolling status of actions like redeploys, updates, and system maintenance. In a real app, progress is based on a complex set of states that changes over time. Reproducing these states with normal use ranges from difficult to impossible. With Chromatic, we are able to step through each state change one by one and refine the display of various states as well as the transitions between them. One last thing. Sometimes you just want to get an overview of basic styling in your app, and parsing through CSS files doesn't cut it. Our Styles page allows you to see the output of base styling common to many apps at once. We've provided reference templates that present reasonable defaults for typography, buttons, and more. Enjoy!
Great, so you got a little peek. Let's talk about how it works. Chromatic lives alongside your app in debug mode. It's a separate app. It indexes all your app's components, so they're easy to find, and it renders all the component states by using developer-defined state declarations and stub data. You access Chromatic, as Tim said, by visiting /style guide in your app. It's available in debug mode only, so none of this stuff will build for production. And you register components with the Chromatic API by providing these state specifications. Let's take a look at a typical React component. You have a class declaration and some behavior. To register it with Chromatic, you have to do two things. First of all, import the Chromatic namespace at the top, and then at the bottom, perform a Chromatic add method call to declare a state that your component can be in. Every state has a name so that they're easy to find in the Chromatic UI, as well as a set of data context specs. So it might be a set of props, or it might be a data context, what have you. It's as simple as that. That's all you have to do. And then you go to /style guide, and you can see your component. We use this tool every day to build Galaxy and everything else we do at Meteor. We're open sourcing Chromatic today so that you folks can build beautiful interfaces faster. This is an experimental alpha release from the Meteor applications team. We rushed this out the door just for you today, and we will continue development as our needs expand and as our resources permit. Also released with Chromatic is this list of packages which are all elements of UI that we've built for Galaxy. Things like our loading spinners, our overlays, a way to highlight blocks of code in your UI are all easy to use with these packages. It's an alpha release, and so we're very happy to see your contributions if you're interested. We're looking for simple ways to smoke test components. We're looking for bug fixes. There's going to be bugs. We're looking for performance improvements if you guys can help. We want to support Angular and Blaze, and of course documentation and these other niceties would also be great. So with that, we thank you very much for your time. Special thanks go to Phil Cofield, whose UI Harness project was sort of the inspiration behind all of this. Tom Coleman and Zultan, of course, who helped refine the style guide for his process in the first place. They created the initial Chromatic prototypes. And Angela Wang, who built the first version of this applications interface. Follow us on Twitter. With that, thank you all.
Questions for Damajanya?
Dan?
Two questions. First, does Galaxy offer MongoDB, or do you have to go to a different site?
You have to go to a different site.
Okay. Second question. My experience as an app developer has been in the Apple environment, and they provide a really good service. They protect your application from being easily stolen, but also they collect the money for you. Is there going to be an infrastructure like that for Meteor?
It's a tough question. We'd probably have to consult with product folks, but I expect that what you're referring to by protecting your app from getting stolen in terms of code signing that goes onto the device,
right?
We will probably continue to leave those things with the platform providers that do that. So if you're using Meteor to build a mobile app, code signing will still happen with the app store you choose to use. In terms of extra application services that we want to give you as an application developer, we've got a lot of things to work on, and we're going to be adding them soon.
Okay. Thank you.
Gentleman back.
When you're building a front end, roughly, what percentage of components did you find yourself pulling from the community, and what percentage of components you're like, you know what, we're just going to build that ourselves. It's there's nothing good out there, but just I don't want to use what's out there. I'm just asking for a lot of time when you're building a front end, you're just like, do I really want to do I want to go to the community to find a spinner, or that's sort of the thing where it's better just to build it yourself?
So the question, if I may, is whether or not we look to the community or look elsewhere to build our components. The problem with discovering components online is that there's no way to actually QA or do any of the due diligence required in assessing the component quality without actually first integrating into your app. So it ends up being quite a hurdle to see if that component is actually right for you. So for us, we were forced to actually build a lot of the components in-house because we couldn't, it took too much effort to like go and assess and kind of filter through the millions and millions of components that are out there. Sam?
How do you currently test your components? Manually, automated? What's your approach?
Repeat the question, maybe?
How do we currently test our components?
Mm-hmm. So the whole thing about automated testing of components is it seems to be a luxury when you have large development teams, right? As you know, writing automated UI tests is difficult, in the least. It's flaky, right? Your tests are going to be brittle. So what we sort of hope to achieve with Chromatic is like the sweet spot, where you have a way of rendering all your component states that allows you to manually test them. Today, at the scale we run at, we don't have automated UI testing, but we certainly make heavy use of Chromatic to do that work ourselves.
We'll give you a couple of pull requests.
Yeah.
Fantastic, thank you.
Maybe we get time for one more question.
One more question? I see a hand.
You guys actually use a competitor too, or something we can live alongside other CSS frameworks like Bootstrap or Materialize?
Yeah, so the question was, does this replace, if I may, does this replace other frameworks like Bootstrap or Material, or does this live alongside? We see this as complementary. If you can register those components into, you can certainly register the components that Bootstrap or Material provides into this component explorer.
I think you might have trouble mixing UI frameworks in general. In particular, the way frameworks tend to reset CSS styles is going to be difficult to mix, right? So I think we certainly think about using our stuff with everybody else's and vice versa when we build it, and we try not to make too many global resets and things like that. But I consider that problem to be impossible by definition. You will still have to do some work to make sure that the two frameworks you're using are going to play nice together.
Thank you, Damajanya.
Thank you all.
Thanks.
Right. Excuse me, fellas. All right. Thanks again, Damajanya. Our second featured speaker tonight is Zultan Ola. Zultan works as the project lead on the Meteor project here at MDG. He joined Meteor last year as head of customer success and previously worked as co-founder of Percolate Studio, a digital agency focused on building delightful user experiences. Tonight, Zultan will tell us some more about the recently released Meteor 1.3. So everybody, please welcome Zul.
What? All right, thanks, Nick, and hi, everyone. So Meteor 1.3 went out earlier this week after many months of development. It's our biggest release yet, and one that I personally have been madly hanging out for ever since the ECMAScript module spec came out. So this release has a few heavy-hitting features, like the modules. And so in this talk, I'll dive into what problems these features solve and why you should use them. So I'll start with modules because they're so dear to my heart. For a long time, JavaScript lacked module support, forcing developers to use the global namespace. And to work around this, competing solutions emerged like CommonJS and AMD. And this was a great start, but without a standard, code written in the two styles couldn't really operate cleanly. So finally, a standard for modules was ratified in ES 2015. So this is really a really important step, I believe, for JavaScript to be taken seriously as a programming language. And of course, it helps a lot in development. So Meteor 1.3 now fully supports modules. And I want to show you some common problems that modules solve in your daily life. So first up, looking at this code, I'm left wondering what the L function does. And this is a very contrived example. I hope no one out there has ever called a function L before. But I'm going to use it to illustrate a point, right? So before 1.3, a situation like this could arise where it's nearly impossible to track down where something was defined. So this is especially annoying or hard if you're working with an unfamiliar code base, written by others, for instance, or yourself a long time ago. Happens to me a lot. So in this case, in a Meteor app, you'd first search through the app. Next, you'd look through your local packages. And if you still haven't found L, you might look in your packages file to see what packages you're using. Next, you'll have to root around in Meteor's internal folder structure to find the source code for the packages, still looking for L. And then finally, if you still haven't found it, it's possible that L it comes from a packages dependency, right? So good luck tracking all that down, and global search probably won't help you there either. So with modules and import, there's a simple solution to this. So that at the top, you can see that L is now imported from this very specific package. So this makes reading code so much simpler and nicer. So even when we know where things are defined, I find it's fantastic to see a catalog of objects that have been imported at the top of your file. You quickly get a feel for the code and the file's dependencies, and what areas the code operates on before you've even read any further than the top of the file. So I think imports are fantastic. Another problem for Meteor is this. You've probably all seen that before. So the default behavior in Meteor apps used to be that all files would be evaluated eagerly, and so sometimes it's impossible to get around this kind of craziness in order to get your load order right. So again, imports comes to the rescue, and it's very clean, it's very simple, and now it's possible with Meteor 1.3 to control load order properly without resorting to hacks. And here's another huge pain point for me. Atmosphere has long suffered from the wrapper package problem, and we've sort of thought about various ways to solve it, but it turns out the sort of NPM support that ships in 1.3 just solves it quite naturally. So to give you a reminder, in order to consume packages from the greater JavaScript ecosystem, Meteor authors had to repackage the original code and upload it to Atmosphere. So this approach came with a host of problems, not in the least pointless labor and lagging versions, and also quality when you weren't sure whether a package was wrapped properly. So NPM, turns out, has come a long way in the years since Meteor has been around. I think if it was in this position when Meteor started out, the project would have just used it. So sometime last year, when I was looking for a simple package called AutoSize, I had the realization that just last year, even some of the less popular front-end only packages were published on NPM by the original author. And that's a really big deal. When you get a package from the original author, it just means that it's always going to be up to date because as soon as they publish it, you now have access to that version. You don't have to wait for a wrapping package sort of author to rewrap the original version. So that's a huge advantage. Plus, you're guaranteed of the quality as well because it's coming from the source. So NPM has truly become the standard JavaScript package repository. And I'm so glad to announce that with Meteor 1.3, the giant wrapper package pain may become a problem of the past. So here's the solution. You use npm install with Meteor 1.3 to natively install the package in your app. And then you import it, and you just begin to use it straight away. And if the original author ever updates the package, it's very simple with npm to just update the package, and then you continue using the new features. Furthermore, packages from other ecosystems like React and Angular that live in npm and are modularized can now be much more naturally consumed in a Meteor app. For instance, in this example, you can see I pull out router and route and link, browser history, directly from within the React router package. This wasn't really previously possible without a complex wrapper package that exposed all of those different internals. So next I want to touch on testing, which is another headline feature in 1.3. Meteor has a long and sordid history with a lack of great core support for testing. Sure, we used to be able to unit test packages with a quirky internal framework called TinyTest, but that was pretty much where sort of core support ended. So pre 1.3, in order to test the app itself, you had to awkwardly break it up into local packages and then test those with TinyTest, which was sometimes a pretty contrived exercise. The great folks from the Velocity team, though, picked up the slack where we left off and built out a complementary testing solution. Unfortunately, we were busy building other stuff like Galaxy and didn't give them the great support that we should have, I think, to make integration with core totally seamless. So when we were developing the new module system, we found that a lot of the pieces sort of naturally fell into place to open the door for a light but solid solution built into core. So I think the module system opened up that possibility in a really natural way too. And in the end, a lot of the code and the techniques that now constitute Meteor's testing story have come from the original Velocity team and the greater community at large. So I thank you for that. So with the new testing support, you'll be able to use any testing framework to test a Meteor app. Today we have Mocha, and in the future we expect us or the community to build other drivers, for other frameworks as well. Thanks to some special naming conventions baked into 1.3, tests can now live next to the files that they're testing, which is a pattern many people enjoy. Although it's not necessary to do that. You can also put tests in their own spot somewhere in the project. And a strong feature that's always been at the heart of Meteor is the ability to test across the client and server divide. So naturally, the new system retains that ability. And it has two modes, unit and full app testing mode. In unit testing mode, your test files are loaded, only your test files are loaded, enabling you to unit test the specific parts of your code that the test files pull in. And in full app testing mode, your application files are loaded as well, giving you the ability to perform integration testing across your entire app. So that's kind of one of the most interesting features, I think, in the new testing system. And so what we've called sort of full app test mode is similar to end-to-end or acceptance testing, typically using a WebDriver based approach like Selenium. So the difference, though, with end-to-end testing is that you're essentially black box testing your app using a simulated user. Your tests don't have any knowledge of the internals of the application and can only do what the user can do. So this is a great way to make 100% sure that your end user experience isn't broken, but it does come with some trade-offs. And the main one is that it's difficult to seed or reset your data between test runs. If, for example, you have like 100 test accounts in your test run, you'll need to create typically all of that data through the user interface. So you create account after account after account, just like a real user would. And things get especially tricky if you need to create an assertion on some dynamic data that must be seeded beforehand, where the test has to match the actual data that you've seeded. So Meteor's full app test mode is a white box testing approach. That means your test code has access to your application's code and also the database. And this makes it much easier and faster to seed data and write certain types of tests. I think it's also easier to set up and maintain, which hopefully will lead to better tested apps in the future. Next up, 1.3 contains a completely rewritten Cordova integration, which includes much better performance, both for your application, thanks to like WK WebView support, and also for loading new app versions when you push an update. And that's thanks to a better download algorithm, and that includes download resumption, which was sort of an obvious feature that was missing previously. And incidentally, that feature leads to lower data consumption as well, which is really useful. So I think combined with the Android crosswalk support that we launched in 1.2, it's now possible to write, I think, like really cutting edge hybrid web apps really easily with Meteor. because all of these great pieces come out of the box that otherwise you'd have to spend a lot of time assembling yourself. And in particular, this is a pet peeve of mine because I've seen it a lot. Was a fault of the previous Cordova system where if you deployed an app that was broken on startup, it would essentially brick the app on the phone. And then you'd have to, once you pushed a fixed version up into the cloud, you'd have to ask your users to basically uninstall the app and reinstall it again to get a working version. So that's really, really bad if you have to do that. You might even lose users over that. So with 1.3, we've included a safety belt feature that means you'll never be in this situation, because if a version doesn't boot, the app will just roll back to the previous version or whatever came from the App Store to begin with. Also, another noteworthy little sort of set of options that we landed in 1.3 gives you the ability to tune live data performance. So we typically recommend that everyone should use oplog tailing for the best performance in their apps. And this is true for most situations, I'd say 95% of situations. But there are some edge cases where the old poll and diff algorithm works better. For instance, when data changes more frequently than your users need to know about, that's one of those situations. So remember that, like with oplog tailing, every single change needs to be processed by the server and sent down to the client. So if you have a lot of these changes that are not important to the user, then you're just generating all of this extra traffic and processing. So imagine like a stock exchange where stocks are being traded really frequently and the users are looking at a stock price. Well, they probably don't need to see the update from every single change. They're probably happy to see a few seconds behind or a minute behind or whatever. So that's a case where the old poll and diff algorithm would be better than oplog tailing for that situation. So we now have this disable oplog option that lets you revert back to the oplog and also set the polling interval and a throttle parameter. I'm not going to go into the details of those parameters because they are covered in the docs, but I think that's a really sort of cool optimization that will help people out. So by now, I hope I've convinced you that updating to 1.3 is a good idea, and it's even worth some minor refactoring. So I'm going to finish the deep dive by going through the steps that I would do to upgrade my 1.2 apps to 1.3. So first off, imports. It's now JavaScript best practice to use import and export, and I expect that'll become the default in future versions of Meteor. So I'd refactor my application code entirely into the imports directory and stop relying on global variables. And then next, I'd refactor my local packages into the imports directory as well. I'm going to savor getting rid of wrapper packages as much as possible. So I'm going to go through my package list to find packages that don't add Meteor-specific functionality and can be found on NPM. And I just NPM install these instead and remove them from my Meteor app as Atmosphere packages. So after or during refactoring code into /imports, I'm now perfectly positioned to take advantage of the new testing infrastructure. So I do that probably by writing tests in line with my application code. If I'm using Cordova, I definitely republish my apps with the new functionality, and it does require a binary update, so you will need to republish new apps to the stores. And I'll point out that because of this binary incompatibility, like 1.2 apps won't automatically hot code reload to 1.3, and vice versa. 1.3 apps won't try and hot code reload down to a broken 1.2. So you'll need to republish and account for that. And then finally, in Meteor 1.3, we recommend installing React directly from NPM rather than using our previously provided wrapping Atmosphere packages. So when I was getting rid of wrapper packages, I'd just naturally use React directly from NPM as well. And we put a huge amount of effort and work into the Meteor guide in the last sort of 4 to 5 months, maybe 3 to 4, and then especially for the 1.3 release. The guide is fully up to date with 1.3. It contains a ton of extra content, and in particular, there's a full migration guide from 1.2. So that lists out the breaking changes as well as the recommended updates that we think you should take. And the guide is the place to go for our opinionated voice on best practices for building Meteor apps. It's how we think you should do it, which is something that the community has asked for a long time, and we've shied away from making opinions, but now we're doing it. So having released 1.3, I can assure you we're not going to rest for very long. Up next, we'll be working on stuff like Mongo driver updates, upgrading to Node 4, and also exploring what a full transition to NPM might look like in the future. And more than ever, we'll be paying attention to your needs and taking contributions from the community as much as we can. So thanks for tuning in, and I can't stress enough that you should update to 1.3 and refactor your code. So thank you.
Questions?
Just related to aggregation and improvements in the node driver, when can we expect them, and what's going on with the actual implementation for the full node driver?
So the question was, when can we expect aggregation improvements from the node driver? And as I just said, like that's something we'll be looking at very shortly, and also updating to like support the latest node 3, Mongo 3.2. Does that answer your question?
As a coder, we need to know.
I'm not going to commit to dates standing up here. I mean, yeah, we just seriously though, like we haven't even looked at a schedule for any of this stuff.
Still married to Atmosphere for a little while.
Yeah.
Very good job.
Thanks.
Other questions for Zultan? So I've been playing around with 1.3 for a while now, like ever since maybe 13 or something. It's been a really good job. I like the module support. One of the things that kind of confuses me is like now if I have to look for something, I have to look for something, in 2 different places. I have to look for it, like when I'm installing React from NPM, and I'm installing, the flow router stuff from Atmosphere.
Right.
So are you guys deprecating Atmosphere, or the answer is no? Can you at least have a one-stop shop where you can say, hey, look, it's over here in NPM, install it there. So I don't have to go looking in 2 different places.
So the question is, are we deprecating Atmosphere, or are people going to have to look in 2 places for packages for the rest of eternity? The answer is, we're still figuring it out. No, that's not really the answer. I think we're going to move to NPM as the package repository for Meteor packages. I don't know whether that'll mean like getting rid of Atmosphere or pointing Atmosphere to a subset of NPM where you can search for just Meteor-related packages.
It would be really nice if Atmosphere was like a curation mechanism.
Yeah.
Where like you can see the graph circle, so you can see what's trending up, what's trending down.
Yeah.
And even if Atmosphere was the one-stop shop that pointed, say, to this NPM repository, that'd be cool. It's just like looking in 2 different places is kind of correct.
Yeah. Yeah, and that's what we've seen from other communities as well that treat NPM as a package store. They often build out other little front ends that like only index the packages that are relevant to them. For Ember, for instance, does this. So that's why I say like maybe Atmosphere might sort of look like that in the future. One more?
So I've seen a number of places people asking questions around whether or not Meteor is well suited for big production big application that need to scale.
Yeah.
Can you tell us a bit about it and how 1.3 might be changing that?
So the question was, can Meteor scale, basically? And 1.3 is the release where we've concentrated a lot on making that, on helping projects scale with Meteor. And the focus for this release has mostly been around scaling teams and code base size. You'll see that I talked a little bit about live data improvements. So we focused a little bit of attention on making the data layer scale, but the large focus in this release is making code bases more scalable. So my answer to people is yes, it definitely does. And where the data layer is concerned, my colleague Sashko is going to talk very soon about how we're focusing our attention on making the data layer part of Meteor scale.
We got time for one more question.
One more.
So you're saying you want to, if you're going to go to modules, you want to refactor everything. So let's say you have a big investment in code base.
Yep.
And what you want to do is you sort of want to take a middle ground approach.
Yep.
It's sort of anything new, maybe I could be building modules, and then as I have the necessary need to go in, I got to make a change, and then I'll refactor as I go along.
Yep.
Is that a valid approach? Or?
Yeah, that's a fantastic question, actually. So the question was, do I need to refactor my entire app immediately if I want to start using modules? Or can I refactor piece by piece, especially as I build out new functionality? And the answer is definitely you can refactor piece by piece. So 1.3 is designed to be totally backward compatible. When you update to 1.3 and you launch your app, it's going to work exactly the same way as it did in 1.2. So we've made modules an opt-in feature. So the way you opt in is there's a /imports directory that now has some special sort of functionality attached to it. And that's where you put anything that's written in the module style. And so you can start now building code in the imports directory with the goal of moving your entire application over into the imports directory one day. And then that's why I sort of mentioned briefly that one day in a future release, we might just say, okay, that's it, like globals are gone. Now your entire app directory just functions as the imports directory. So one day I think we will end up doing that. But for the meantime, it's strictly an opt-in mechanism.
Yeah, so is that one day, like 6 months from now? A month from now?
It's 2 weeks. Just joking. No, yeah, it's probably a long way down the track. Yeah. Cool.
Just one more thing. Wrap async, you still got to worry about wrapping of fibers or is there any improvements?
Yeah, we haven't done any. So the question is wrap async. So we haven't done any work yet to deprecate fibers. So you will still have to wrap async. Yeah. Cool.
All right, thank you, Zol. All right, so let's move on to our third featured speaker tonight, and that is Sashko Stubailo. Since graduating from MIT in 2014, Sashko has been involved in all of the major Meteor releases and has worked on some other projects as well. He was one of the authors of the Meteor Guide, which you can find at guide.meteor.com, and worked on Meteor's React integration as part of 1.2 and Windows support as part of 1.1. He's also been very active on our forums, where many of you may have run into him. Currently, Sashko is the tech lead on the Apollo project, the data stack for modern apps. Tonight, he'll tell us a little bit more about the Apollo project. So everybody, please welcome Sashko.
Hello, let me just set up this projector. Okay. Somebody told me that I can see notes on my screen if I make it not mirror. I'm going to do that. Let's see if this works. Oh. There we go. Oh, yeah, it worked great. Wow, good job, Apple. Yeah, so today I want to tell you a little bit about a new project we're working on. You could call it the next big project of Meteor. We just finished up, well, I wouldn't say finished up, but we just launched Galaxy, and I think the next big exciting thing is going to be Apollo. And for some of you, you might be aware of what we're doing already. We had a couple of blog posts. We have a GitHub repository, a lot of stuff like that that you could have kept up with. And I imagine for a lot of you, you haven't heard of Apollo yet, and so you're wondering what it is. So this time, I'll start from scratch. So if you've never heard of it before, you'll find out what it is. So Apollo is the data stack for modern apps. Meteor includes the data stack. Apollo is the next generation of that data stack inside Meteor. And we'll talk about what that means, and you'll know exactly what that means by the end of the talk. So you're here at Meteor Night. You're probably familiar with Meteor. And by the way, congratulations to the Meteor team on the awesome 1.3 release. Like, this is kind of what I wanted since I started using Meteor. Like, it's mind-blowing. Anyway, Meteor does a lot of things. When Meteor started roughly 4 years ago, the JavaScript world was a totally different place. Client-side rendering was like, just becoming a trendy thing that people were like, should I be client-side rendering? I don't know. Now it's like the thing that everyone does. Writing JavaScript on the server was also pretty crazy. Node.js was just becoming a thing. In short, to make Meteor a great developer experience, you needed to build out a huge amount of infrastructure around everything just to be able to get an app off the ground entirely in JavaScript. But I think personally, the most exciting part of the Meteor developer experience has always been the data system. Because even today, when you look around, there's really great alternatives for a lot of the parts of what Meteor started out with. For example, you can use React for the view layer. There's all different kinds of routers. There's different kinds of build tools, languages that compile into JavaScript, stuff like that. But only very recently have we started seeing tools and frameworks that revolutionize data loading in the way that Meteor did even back when it first came out. I think the main achievement of the Meteor data system was making the client-server divide a lot less of a burden. The same way that you can run the same code on the client and the server with JavaScript and isomorphic build tools and stuff like that, Meteor made it so that you could sometimes pretend like your data was both on the client and the server, even though it wasn't, which meant that you didn't have to constantly worry about getting your data from place to place. So let's talk a little bit about, in detail, what made Meteor's data system so different. Oh, there's some animations. OK. This is a great slide template that Dom made for us. So before Meteor, people were likely doing imperative data fetches. They were saying, man, I'm trying to render this part of my UI. I probably want to fetch some data right now. So you would call a function that's like, get this endpoint. You would like put it somewhere in your component. Meteor made that all essentially declarative, right? Instead of saying, I want to fetch this data, you say, I'm interested in having this data. And then Meteor would push the data to the client for you using subscriptions, right? You could keep open as many subscriptions as you wanted, read from them at will, close them when you're not interested in them anymore, use tools to preload data before you need it. And that was much easier, I think, in Meteor than other systems. Also, for your API, instead of having a list of endpoints where you just call a function that calls a URL, you get back a random JSON blob of data, who knows how nested it is or what's in there. Meteor came built in with the concept of the identity of objects, right? Borrowed from MongoDB, the fact that every document in your database has an ID, right? So when you're using your data on the client, it wasn't just reading a JSON blob. It was querying a set of collections by ID or by different queries, so you could feel like you were really in control of your data, and it wasn't just whatever the backend happened to give you. And the last thing was, instead of making independent requests, right, each time you load a new part of the page, you load a new part of data, you had a stateful client-side cache, which meant that you could be aware that the client was keeping track of all the data that it had. And so, if you go back and forth from one page to another, you wouldn't necessarily be loading all the time. You might be able to reuse some of the data you loaded before. And so the question is, how can we take some of these, what I believe to be the core benefits of Meteor's data system and kind of Meteor itself, and bring it to everyone? And when I say everyone, I mean literally everyone. I mean people who are writing their backends in Go, people who are writing their frontends in Swift, people who don't have reactivity in their apps, people who are using Salesforce and building a UI on top of it. So Apollo is the idea that we can take a data system like Meteor's and make it work in almost any type of application, and take the legendary, neat developer experience that bridges the client and server and make it work without compromises, right? Because right now, when you use Meteor, you're saying, I want this great developer experience, but at the same time, there's situations where you wouldn't want to use Meteor, right? Like, let's say you're writing a static website. Like, maybe the data loading stuff isn't as scalable as you would like it to be. And so how can we make this happen? So the more we thought about this, the more we realized that we needed a new way for the client to specify its data requirements. So in Meteor, the client specifies its data requirements currently using a set of subscriptions and then using a set of MongoDB queries. But there's a couple of reasons why this isn't optimal when your database is not MongoDB. I mean, the obvious reason is, why would you query your client-side data in MongoDB if you're querying it using SQL on the server, or a REST API, or the AWS SDK, or something like that? So the first thing we needed is a query language that was decoupled from your backend data services. And the second thing is, we needed a more semantic way to tell the server what data you need. Because right now, you just get to call a subscription, and you pass in some arguments, but the server at the end of the day decides what fields you actually wanted. And there have been some advancements in this, right? There's like publish composite, which are some packages that let you send a whole bunch of data that's relational and stuff like that. And those are great, but we really want to give the client the power to ask for exactly the data it needs. And so that's why we decided to go with GraphQL. And I think if GraphQL didn't exist, and thank God that it does exist, we probably would have had to invent something like it. But thankfully, the good people at Facebook came up with it for us. So just a super quick crash course on GraphQL. If you haven't heard about it, which I think a lot of people haven't, it's basically a nested query language that maps onto a set of functions and APIs on the server. So you essentially pass the shape of the data that you want and the kinds of objects that you want from the client. So the thing at the top right is the query you would pass. And the server resolves it to an object that is shaped exactly like the query that you passed in. And you can see that there's some nested objects in the query and in the response. Those can be traversals to entire different objects in your backend, right? So if you have a user and that user has a profile picture object, this field might be traversing to a different collection in your database, or maybe a different backend service entirely. Or it could be the GitHub API, like who cares? It can be anything you want. And so this is just a quick primer to understand the rest of the talk, but you can learn more both by reading on the GraphQL website, and also we have a Medium publication where we've been posting a lot of stuff about easy ways to learn GraphQL. And one last thing before we jump into what actually Apollo is, because there's kind of some abstract goals for it, is the importance of having clarity about how your application is working. Meteor has often been referred to as magical, or something where you use it and you say, wow, like how did that happen? Right? You go through a tutorial, you're like, I clicked the button over here and on this client it changed. Like, that's crazy. And that's really, really cool. And I think that's something that we want to maintain. I think the thing we want to add on top of that is a really easy way to get insight into exactly what's happening. So you don't necessarily want to build all the parts of your stack yourself, right? That would just lower your productivity. But at the end of the day, you want to feel as if you could have, right? You want to feel like, if I wanted to build this from scratch, I could because I know exactly how it works. I'm not going to because the Apollo version is much better, but you could. So let's go into what it actually looks like when you have your app like this. So this is kind of a diagram of what a big production app would look like on Apollo. And let's be clear, if your app is very simple, you just have one database, one client, the diagram will obviously be much simpler. But the point is, we're thinking ahead to the larger apps, the scalable apps with lots of different backends and frontends. And actually, if you worked on an app before that has a bunch of microservices, REST APIs, a bunch of different clients, you might actually be familiar with this diagram because a thing that a lot of people are doing now is building a thing called an API server or a backend for frontend or BFF. And so you might imagine this box in the middle. Sometimes people build a Rails server that takes in all their microservices and exposes exactly the kind of API that their UI wants. But that doesn't work very well because it turns out that when you're using something like a REST API and you want to minimize the number of requests you're doing, you want to make sure your data fetching is very efficient, you need basically very specific APIs for every single one of your UIs that you're writing. And sometimes your backends don't give you the data in the shape that you want. And that's where GraphQL and Apollo come in to make that super easy for you. So we've seen what GraphQL queries look like. We've seen what the general architecture is. We have some clients, some servers, and a proxy layer in the middle that is running on the Apollo server. And see what happens when you send a query from the client. So here's what happens. The UI will declaratively specify what data it wants in the form of a GraphQL query or set of GraphQL queries. The Apollo client will diff those queries against the local data that it has in the cache, much in the same way that you might have some data in Minimongo already today in Meteor. It will take the query that represents the data you don't yet have and send that to the server. The server will aggregate the data from the different services that you need to access, whether those are APIs or databases, send that result back to the client. The client will update its cache and deliver the result to the UI. And so from the point of view of the user interface, it's as if it just asked for some data and then it got it. But there's all the machinery going on under the hood to give you the same beneficial experience from Meteor that you get from being able to pre-cache data, preload it, manipulate it on the client, and do stuff like that. So let's make just a more detailed comparison between DDP and what we'll see with Apollo and GraphQL. So in Meteor, you have to first subscribe to your data, then query it on the client, right? You first call a subscription, then you pass a Mongo query. In Apollo, you just query it and you get the data, and the cache works silently under the hood. In DDP, in Meteor, the server decides what to send. In Apollo, the client decides what to request by sending a GraphQL query with the exact shape of the data it needs. In Meteor, the reactivity comes from live database queries. Right now, we have a very fancy component that watches MongoDB for changes and delivers them to the UI. Unfortunately, it only works for MongoDB. So in Apollo, the reactivity will be built on top of a request-response model, which means that if you can build a function that fetches the data from your backend data source, we'll figure out how to make it reactive for you if you want to. But if you don't want to, it doesn't have to be reactive. In Meteor, the schema lives in something like simple schema in your user code. It's up to you to provide the schema on top of MongoDB. In Apollo and GraphQL, GraphQL has a schema built in inherently. You know exactly what data your server can give you just by writing that API in GraphQL. And then there's a couple other things, but the most important thing is Meteor gives you a database query language to access your data on the client, whereas in GraphQL with Apollo, you have an application level query language, which is designed not for the needs that you have when you're fetching data out of a database, but for the needs that your UI has when it's fetching data from a server. So let's go on to what we're actually building, right? It's still kind of a 10,000-foot overview of the architecture. So, I wouldn't want to get into this without talking about what a lot of really smart people have already done, mostly around different tools about GraphQL, Relay, stuff like that. So all the stuff that I talked to you about just now, about diffing the queries and loading only the data you need, Relay actually already does all those things. So Facebook has created a really great template for a very smart library that does a lot of this stuff. Facebook also has some great reference implementations for how you might be able to implement a JavaScript GraphQL server. And so our goal is to stand on the shoulders of giants, take all this stuff that we think is really, really awesome, and combine that with our experience building really awesome developer experiences, the thing that got me to want to work at Meteor when you use it, and it's just so much fun that you want to keep building stuff. And we want to combine these to make using GraphQL and Apollo in your app a total no-brainer, whether you're writing a native app or whether it's a JavaScript application, whether it's in Meteor or you're using Webpack. We want to make Apollo the right choice for you. And so here are the first two components that we're building. The first one is the Apollo server, which my colleague Jonas is working on, and you can read his posts about this again on the Apollo Medium publication. It's going to be a super simple GraphQL translation layer that you put on top of your existing backends. So, like I said, you can fetch from as many backends as you want. So we want to make the most natural way to convert a set of microservices, a set of external APIs, and a set of databases into a GraphQL schema that you can query from the client. Whether or not you use the Apollo client, whether you use Relay, whether you use Airnode as Loca, or whether you use a simple post request, it doesn't matter because this is just a generic GraphQL server. It'll let you have a declarative schema so you can, at a glance, decide exactly what data you can fetch from the server. It'll have some translation code, and it'll have a standard GraphQL execution engine. And you can, if you're interested in this, check out our GitHub repository and contribute at apollostack/Apollo server. And the next part that I'm working on right now with lots of great help from contributors in the community, people are really jumping in and helping us out. It's a Relay like client that can be incrementally adopted in any application. And so what I mean by Relay like is that it does all this caching, optimistic UI, pagination, all the stuff that you love in Meteor and more, but in a way that can be adopted in any app you're building. First, only in JavaScript apps, but later also in native apps built in Swift or Java. And it has a razor-sharp focus on transparency, simplicity, and ease of debugging. We want you to know exactly what queries are being made, how those queries got generated by your UI, and what kind of impact that's having on your database queries and APIs on the server. And that's something that I actually haven't seen in any system yet, because Meteor gives you the magic, but it doesn't always give you the best insights about how it's working. And this is something we're working on at the Apollo client repository, right? They're not very creatively named, so that's good. And so basically, this is just a quick introduction to what we want to build, how we're getting there, and what we're doing right now. And I think that the goals that we're trying to achieve are really, really exciting, and I hope that I can come back to you 5 or 6 months from now and say, no matter what app you're building, you're going to get a benefit either in performance or ease of development or debugging if you switch to Apollo. And please follow us on Twitter or GitHub, or check out our Medium publication where we blog about various things related to GraphQL or Apollo, and we're always looking for contributors. So please let me know. Thank you.
Questions for Sashko?
Come on.
Yeah, what's your proposed timeline? I mean, so in terms of what you think you'll have, one or either one of these first two pieces complete? Like, what do you guys target?
So the question is, what is our proposed timeline? When do we think we're going to have one or two of these pieces that we're building first? And it's a very aggressive timeline. We actually expect some of the people who are contributing to this library to be running in production next week. So this is not a vaporware. Actually, somebody called it vaporware on Twitter a while ago. It made me feel really bad about myself. But no, we're actually building real technology. It really works. I've built some demo apps with it. People are going to be running into production next week. And Meteor Night happened to be this week. If it was next week, I probably could have given you a better demo. But I'll come back and I'll have some really sweet stuff. Or if you follow the Medium publication, you don't have to come to Meteor Night to hear about that. Sam.
So with the Medium publication, the forums, Apollo, how many Sash codes are there?
Sam's asking, with all this social media stuff, publications, forums, Apollo, Meteor, like, how many Sashkos are there? And I like to think I just use my time in the most visible way possible. So I'm just very efficient. No, but there's only one. As opposed to Aeronota, of which there are thousands. So.
Updating the client-side cache, you said, or I read the design, it's supposed to have like an invalidation server. What's the status of that?
Yeah, that's right. So if you read the question is, I talked about updating client-side cache. We released a design for reactive GraphQL on our blog and also on GitHub maybe a month ago or 2 months ago that involved an invalidation server, which was a thing that piped messages from your server to your client to tell it when it needed to refetch data. So that's one of the things that we're not building yet, asking about timeline before. Right now we want to focus on building a really seamless experience that is not yet focused on reactivity, because we think that the majority of apps will actually want to have reactivity for only a small selection of their apps. We're even seeing this from our production Meteor users today, that reactivity always has a cost, and you want to be judicious where you turn that cost on. And in Meteor, unfortunately, if you turn reactivity off, you actually lose a lot from the system if you start fetching your data with methods or something like that. So we want to make sure we have a system that works really, really well in a non-reactive state, and then put the reactivity on top of that. And whether that works through having a caching proxy layer or an invalidation server, we haven't exactly figured out what the best way is yet.
Databases are just going to support out of the gate.
The question is, what databases are we going to support out of the gate? The number one database we're going to support out of the gate is a REST API. Because in Meteor, we support a database, but it turns out that a lot of data sources out there cannot actually even be listed on a set of features, right? If you have some legacy service that you're talking to, or a payment system, or something that some guy threw together in Node.js once, there's no library that will help you fetch that data, because all the data is totally unique. So we want to start out by building a system that lets you have totally generic data fetching without being coupled to a database, and then work up from there to have things that are optimized for specific databases that maybe reduce the amount of code you have to write, or maybe they give you built-in reactivity or something like that. But the main goal is that you could take your existing app with backend APIs, maybe it already even has a front end, and put this in the middle and get a huge benefit. One more question, yeah.
Is there any memory hit for using this over other methods to post and subscribe that we should be aware of?
The question is there going to be any memory hit of using Apollo over some of these other systems? I think no, because one of the main goals of the system, and we're maintaining this from our design documents in the past, is that the server doesn't have to keep track of almost anything. In Meteor, the server has to know a lot of information about what data the client already has in order to send it only the data that it needs. In Apollo, the client is going to take care of that, which is going to come at the expense of sometimes using a little bit more network, but we think it's better to waste the network a little bit than to overwhelm your server with memory to store stuff. So yeah, the goal is actually that this would not require any more memory or load on your system than any REST API or HTTP request would. Cool, that looks like all the questions. Thanks.
All right. Thank you very much, Sashko. Next up, we have our Built with Meteor app showcase starting in a few minutes. First, we're going to take a short 5-minute break. We've got 2 really cool apps to show you guys tonight, so I hope we see you back here shortly. If you're speaking, please come backstage now, here to my left. Everyone else, go ahead and stretch your legs. I'll see you here in 5 minutes. Thanks. All right, everybody, we're going to get started with our Built with Meteor showcase in 1 minute. We're going to get started in 1 minute. So everybody, please take a seat. We'll get started then.
All right, everybody, we're going to go ahead and get started with our Built with Meteor app showcase for tonight. So everybody could please end their break conversations. We're going to go ahead and dive right into these two great apps. So like I said, we have our Built with Meteor app showcase going on now. During this part of Meteor Night, we showcase cool apps from around the community. If you're interested in demoing your app, you can find a link to fill out the form at livestream.meteor.com. And if you guys right there in the middle could stop your conversations, I would definitely appreciate it. If you're here in person and you're interested in demoing your app at a future Meteor Night, you can come and talk to me after everything is over. We've got two apps to show you tonight. Talks will be 8 minutes long with a couple of minutes for Q&A at the end. First up tonight, we have Yan Yu. Yan is a founder of Parlay Technologies, a startup fixing the contract collaboration and negotiation process. Previously a senior systems engineer at LucidWorks, Yan has architected and deployed Solar and Lucene search solutions for Fortune 500 companies, startups, and everything in between. Yan was also a software engineer at Basis Technology, working with natural language processing, machine learning, and internationalization. Tonight, Yan will tell us about Parlay, a tool for streamlining and centralizing contract negotiations. So everybody, please welcome Yan.
Hey everyone, I'm Jan, and I'm a founder at this company called Parlay. And today I'm here to show you guys the app we've built, but more generally I'm here to talk about how Meteor has been great for us for quickly building a business-targeted application, an enterprise application that fit a specific business pain point that we found. At Parlay, we're making it easier to discuss, collaborate on, negotiate contracts. Has anyone here ever bought or sold software for their company, maybe, that required a contract to sign? If you've gone through that contract process, you might remember it as being particularly complex and taking way longer than you expected. So to give a bit of background, my co-founder and I were selling that software to people. At our last company. We were selling software to giant companies and small companies. And in all these cases, we were talking to procurement teams. And we personally saw how universally in all these companies, no matter how big or small, how convoluted that software negotiation, that contract negotiation process was. There are lots of stakeholders on both sides. There's IT, there's legal, finance, operations, management. And all these people have to communicate with each other. But they don't talk together. They talk one-to-one, and they're sending documents back and forth, and they're trying to get the whole picture, but no one really does. And so it's a really fragmented process, and that's a lot of why it takes so long. And so we talk to these customers, and we'd ask, often huge companies, and we'd ask them whether the process was good, whether it worked for them. And they just say, that's the way it is. Email and MS Word are what we use. That's what we used before. That's why we've used other companies, and that's just how it is. And so we decided that we want to make a company out of that. And so at Parlay, what we're trying to do is tackle the problem of helping groups of people in different companies collaborate and negotiate around a contract. So based on that, as you can tell, Parlay is a pretty specific product that we're designing around a relatively niche market. In all honesty, it's not the most complex technical product. You know, it's not pushing the boundaries of computer science, but it's a real pain point that we've seen over and over. And there are people that would pay money for a solution that fixes for them. So since we found that idea, since we found that kind of seed of an idea, we've continued to learn more about it by talking to more people that deal with contracts. And we spent quite a bit of time just figuring out the general requirements of the solution, trying to figure out what we needed to build. And once we figured out enough, we started the development process. We've been working with Ian Serlin of the Useful.io team, and with them we decided to work with Meteor as our prototyping framework for this. So from having nothing, we had just some drawings, some user feedback, some high-level design documents. It took us 3 months. In 3 months, we built an application from the ground up with the Useful.io team that we brought back to those initial customers that we talked to. Those procurement people, they saw the application. They played with it. They were starting to understand through feeling it and seeing what it could do for them, how they could use it in their organization. But most importantly, we're actually now negotiating with some of those customers and turning them to real customers by negotiating contracts through our own application. So now that I've gotten kind of all the market stuff out of the way, I want to show you a little bit about what Parlay actually does and how people are using it. So So this is the Parlay dashboard. Parlay being contract negotiation, each of these roughly represents a contract. So I'll just jump straight into one. If you've ever used Microsoft Word, you can see that this document has already been redlined. You can see that they're kind of sorted by color. They all have a number that corresponds to them. And these numbers are how we kind of keep track of changes within these documents. And so these items here, they're numbered. They have their own threads. They exist on their own apart from the document. And I can go ahead and accept or reject any one of these given items. And if that reminds you a little bit of GitHub and pull requests, that's because that's exactly what we're modeled on. So we thought about, for example, in the beginning of maybe even using Git for some of this stuff, but we found that with Meteor and Mongo, we actually could build a pretty light version control system that handles our specific use case really, really well without having to resort to other packages like that. And so when I go ahead and accept this item here, that goes ahead, does some logic, and merges that back in. And so on the left side here, this document representation is actually using a project called Quill.js. And Quill.js is another tool that we found really, really helpful insofar as the data representation for Quill is really, really explicit. And combining that with the way that Meteor stores and syncs information, we can actually do some really light kind of operational transform stuff without needing anything more than just those two projects together. And so, like with pull requests, the way that I would go ahead and create one of these items that I'm talking about here is to go ahead and highlight a section of the document, delete a whole chunk of it, if I can highlight properly, and publish that item. So as these items are created, me as the lead for one side, I can approve items that have been created by the other side, and any items that I create have to be approved by the leader of the other side. And so what that means is that the document only changes when both sides approve of a document change. So you'll note that there's a little highlighted 3 here for showing that something's happened. This external chat acts as kind of a news feed. And this is really important for people working in the enterprise because they need to understand what's changing these documents over time. You can't rely on email chains. You can't rely on text messages or conversations that you had that you put in notes. So from the very beginning, we actually log all changes that happen to this document. And you can see down here that I accepted item 2 here, that the document version changed as a result, and that I created another item just shortly after that. And so the thing is, when you have all this information in here, when you have lots of stakeholders viewing this document, what will happen is things will get really confusing really fast. And so we actually allow you to click on item references in here and immediately filter this down. So again, Meteor having a lot of this stuff built in, being able to query the Mongo database, pull this information back, lets us create better filters and better ways to represent information for these enterprise users. I can then go ahead and maybe even reject this item, and it'll record that as well. So then, on top of the external chat, we also have an internal chat. And the internal chat is not quite as full-featured yet, but that allows teams within Parlay to communicate with just each other. So here I have 2 sides that I can invite people into, or rather I can invite people to my side. And then now me and just Dave can communicate separately, apart from everybody else. And if we want to communicate with the other side, we go back to the external chat. And then jumping back to kind of other stuff that's important, we can actually create additional parlays here, and we have built in the ability to import documents via drag and drop. And this is using Mammoth.js, which has been pretty good for us. We're thinking of maybe changing to another project just because we need more of a WYSIWYG import, but that's just kind of the last piece of technology we're using here in the stack. So yeah, that's where we're at. We're currently fundraising. We are building this out and selling to customers, and that's it. Any questions?
Questions for Jan?
Yep. Let's get out of the way. What'd you build the UI with?
Oh yes, what do we build the UI with? I think we just used Blaze. Yep, so it was there and it was the easiest thing we could do. That was what they had the most experience with, so we didn't want to mess with it too much. Yeah?
So you said you used Quill.js?
Yes.
And you combine that with, so what was Quill.js?
So Quill.js is a WYSIWYG text editor. That's basically its entire purpose. I can't remember the guy's name who built it, but it was actually recommended to me by another friend who's worked a lot with kind of these simultaneous document editing tools, and it's built specifically to handle operational transform. Is kind of its whole purpose in a lot of ways, and so we started off using that for exactly that purpose. And you can find more of it at quill.js, I believe. Yep.
Did you ever think of experimenting with like natural language processing, where people can like, because you had a whole chat piece in there, where you could actually sort of automate some things in a natural language kind of way?
So the question is, have we ever thought about using natural language processing, maybe around the chat, around the documents, and things like that, right? Yes, with my background, I mean, I've thought a lot about that. There's a lot of pieces around contract analysis that are really interesting to us. In specific, when you're dealing with large organizations that are pushing out these contracts every single day, if you can analyze all your contracts and figure out this piece is negotiated 80% of the time, this piece takes 60 days to negotiate every single time, you can start making it more efficient for your organization to get through these contracts faster. And then you can apply that to chat as well and figure out more of that, get analytics on how your people are communicating. Maybe you shouldn't use this word in your negotiation anymore, stuff like that. Okay, thank you very much.
Thank you, Jan. All right, thank you very much, Jan. Next up, we have Santiago Siri. Santiago is a founding peer of Partido de la Red, which is a political party that aims to improve representation with candidates committed to online citizen requests. He's also been an advocate for Bitcoin since 2011, and in 2007 founded Popego, a pioneering big data research lab. His first book, Hacktivismo, was published in 2015 by Random House. Tonight, Santiago will tell us about Democracy.Earth, a Y Combinator-backed nonprofit working on a global effort to deliver an open source solution to online voting. So everybody, please welcome Santiago.
Good evening, guys. So usually by the end, when you release something, you are ready to make a demo, and actually we're on the very early days of the development of this. So many things won't work probably, as it should on any demo. All right. So Democracy.Earth. I will give you a little bit of what I've been working on for the last 4 years and what we're looking into the future and what we're actually building with Meteor these very days. So we started 4 years ago with the mission of hacking politics. And we started in Buenos Aires in Argentina. And our first attempt at trying to do this was to perform a very well-known hack that has been done throughout the history of civilization, that is the Trojan tactic, trying to change the system from within. So this was our first attempt, our first tactic. And the way we did it was the following way. We developed an open source software called Democracy OS, a very simple application where you get informed, you debate and vote, kind of like a do-it-yourself Facebook. But this open source application also came with an offline component called Partido de la Red, literally a political party. And this political party has candidates that are committed to always vote in Congress according to what citizens decide on Democracy OS. It was a radical approach, especially for Latin America and a city like Buenos Aires in Argentina, but we actually went out and did it. We literally built a Trojan horse. We campaigned in the streets of Buenos Aires. We went for elections in 2013, and we got 1.2% of the votes. The Partido de la Red made a very good first election for a very small party. It was a big success for us to get 1% of the votes. And since then, Democracy OS, it was not enough to get the candidate elected, but we kind of got the software elected. Democracy OS was implemented by the by the Congress, City Congress. All 16 parties agreed to present a bill on the platform, got the citizens engaged, and we started seeing how the software played out. Democracy OS is a very simple app. It's developed in Node, MongoDB, and it was its main feature is the fact that it's open source. But its development throughout the last 3 years It changed teams, and we had different teams working on it throughout all these years. But it led us to understand how we can do digital activism. We work with governments, federal governments, local governments, political parties, nonprofits. It was localized into 18 languages, has over 1,000 stars on GitHub. And it was a project that led us to understand a little bit about the intersection of politics and technology. But we identified our real enemy, corruption. Many stories about starting up a political party in Latin America. Just to name one, I was asked to pay a bribe to a federal judge in order to run for the 2015 elections in Buenos Aires. Obviously, we did not run because I was not willing to pay a bribe to a federal judge. But the key problem of corruption is something that went beyond my wildest, forecasts of what could, how nasty the game really is. So, and also with Democracy OS, we found some key flaws that needed to be addressed. The fact that any single person that actually controls the server running Democracy OS, regardless of the fact that the application is open source, still whoever manages the server has a lot of impact and a lot of influence on how the application works. So we went out, we told our story to the world, we met a lot of politicians, but we built a healthy network of activists in many, many countries. And last year, we received a call from Y Combinator to build a nonprofit here in Silicon Valley that really focused on the problem, on the issue of democracy at a global scale. And that's where we started the Democracy Earth Foundation. So now we're going with a different strategy. We're doing 10x improvement. What we need to figure out is how we do 10x improvement of government, how we can do governance in a digital way. And the interesting element for us is, we're going to focus on precisely voting. And the key thing about voting is that it's already the main interaction we do online. It's the main interaction we do on Facebook, on Twitter, on any kind of social network that we use daily. But the interesting thing about the new wave of decentralized ledgers and these new technologies is that now we have an opportunity to work with a technology that its main feature, and I think this is probably the most interesting element to us about the Bitcoin blockchain, is that it's an incorruptible database. Databases are the institutional reality, and whoever manages and gets the rights to write those databases has a lot of power. The fact that we can work now with an incorruptible database, or a database that is extremely expensive to corrupt, is a very interesting opportunity, so we can start imagining new ways of building institutions, doing governance online, and doing voting online. So that's what we're building today is focused on 3 key things that I want to talk to you about. The first key thing is identity. Identity is very centralized. We use passports to move from one nation state to the other, or we use passwords to move from one corporation to the other. The beauty of a technology like the Bitcoin blockchain is that it really can deliver a new protocol that can put our identity keys in the supercomputer we use every day, or smartphones, rather than delegating that power to a centralized authority. And this is very important when you speak about voting, because what differentiates an election from a survey or a poll is proper identity verification. And identity verification also is, we have to keep in mind that when you are expressing political preferences online in certain countries like Venezuela or Cuba, you run a risk of losing your job if you are identified. So the right to manage your anonymity online is also extremely important. The other key element that we are working with is legitimacy. Who gets to count the votes? Who watches the watchman? Nation states have the central authority that gets to count the votes. Corporations have the servers that get to count the likes. But if we use a distributed, decentralized ledger like the Bitcoin blockchain, every single voter can count the votes of every other voter without even requiring access to our technology, to our apps, to our servers, to our software. So we are open sourcing the element that needs to get open source. Open source is not simply about literally opening the source code of a piece of software, but it's about opening the black box that has the risk of actually corrupting the system. And the black box in democratic systems is who gets to count the votes. So using the Bitcoin blockchain, and we're also exploring smart contracts with Ethereum, has very interesting, brings very interesting legitimacy to the system. And finally, representation. Traditional politics, we have reality show politics for nation states, with literally reality show stars actually, running for the top seat of the game, and fake voting that has no institutional impact whatsoever. What we're working with is, this idea of delegating power to your peers, delegating voting power to a friend, to someone you know, to someone you already trust, and work in a more dynamic way of representation. So, Democracy OS, you can check it out. It's out there, but it has a big flaw. If you go to the demo we have actually on democracyos.org, you will see that most of these things here are tests, basically testing the app. And there's not much interaction with it. Most of these are just people testing how they can use the app. So what we need to do is something that really, is able to engage users when they generate the content and engage with the app. So this is what we're working on right now, and this is not even 0.1. This is the very early days of what we're doing. But the great thing about Meteor is that we were able to generate a very simple interface right away. So this is an editor, as you can imagine. I can, really change the interface really, really fast. Automatically saves the information on the database. The editor has, we're using some libraries that enable kind of medium-like editing capabilities. The idea of tags is really important to the system because we are doing delegation based on tags. You delegate power based on a certain set of topics. So we did a very simple, straightforward tag editor. This is also adaptive, works on mobile devices, so it's thought to work properly on mobile devices. And then the ballot design. We were able to implement a super fast search engine. If I can, for example, look here for real incremental search, I type just 2 words and I add an option to this ballot. These options are other decisions that are part of the system. Let's see, Julian Assange, or why not, our good friend Donald Trump. And we just add the options and you design a ballot and then this is sent into the system. We are in the very early days of developing this. We're looking at certain technologies that can help us integrate with the Bitcoin blockchain. A particular piece of technology that we're working with is Blockstack, blockstack.org. It's a protocol for decentralized identity and decentralized DNS management. So it's really interesting, and we're looking into integrating our application with this in order to do identity authentication. And you can visit democracy.earth. This is our current landing site, and leave your information there. And you are looking to build a team that can help us develop this technology in the best possible way. And you can also look for us on Twitter. Thank you, and if you have any questions.
Questions for Santiago?
Use the block cipher to identify the votes or count the votes for candidates or both?
Blockstack is it registers identities, and you have a private key that connects to the public key of the identity that is stored it uses a virtual chain that is connected to the blockchain. The idea is that you get to decide if you want the votes. We won't be connecting them to identities. You get to decide if you want to encrypt the vote of your identity. Yeah, but if you want to vote anonymously, we want to give you that option as well. We want to put that option in the user.
You mentioned delegative democracy. Can you explain like what that means in contrast to like representative democracy or like a democratic republic, or just generally what the political ideology behind this?
Great question. So, what do we mean? What kind of democracy we're talking about? Direct democracy, representative democracy. So, a typical thing that is being talked a lot in many, civic environments is the idea of liquid democracy. This is a model where you vote directly on issues or you delegate your voting power to someone. But to us, the view we have about this is that democracy is always a work in progress. It's always an incomplete idea. If a democracy were, an absolutist idea, it would be a totalitarian ideology, just like all the other ideologies. It's the one exception. The key thing about democracy, when you look at the origins of it, is that the Greeks spoke about agora, and the word agora etymologically means thinking or speaking with others, and it's usually an antonym of making war. And the beauty of that idea is that it has been evolving throughout history, the history of civilization. And what we are trying to really understand here is what democracy means on the digital age, on the internet age. And democracy in software form has the possibility of interaction in many, many more ways of the traditional democratic systems that we have seen in our governments, in our countries, and in our political systems. And I think Wikipedia is a great example of a democratic environment that has very, very interesting dynamics and also has very interesting play out of power. What we're trying to do is to provide a toolkit that can help any kind of institution, small or large, to organize their decision-making process with a governance tool like this, where you can see the decisions being made, where you can provide accountability for the decisions that were made, and bring more transparency to organizations of all sizes.
Great project, congratulations.
Thank you.
I wonder, which country do you think that it could really make the biggest difference in first?
So we were lucky to work in many different countries, in many different contexts, local level, national level. My main concern is that I work with a lot of politicians. I would not work again with politicians. The key thing, and they're reptilians. I'm very sure about that. The key thing is to reach the citizens. The best piece of civic technology that we have seen so far is actually Twitter and Facebook. It's the technologies that we use every day and we engage with every day. So it's key to understand how we can reach the bottom line of it, that is citizens. In our experience, we see that in the developing world, there's a more urgent need for change because traditional institutions just simply not deliver what they need to deliver. So I think it's no coincidence that we actually started in Buenos Aires in Argentina, which is incredibly very corrupt. I'm very ashamed to say that. But it's because of that citizens are looking and flocking into new alternatives. In our experience, we had work in Mexico, we had work in Venezuela, in Chile, across all of Latin America. Brazil is actually very big for us. Also, we've seen implementations of our software, of Democracy OS, in France, in Hungary, in Tunisia. Different uses, specific project that lasts 1 week to 3 weeks. You see how it unfolds and how it's being tried to use for one side or the other. But that's why with democracy.earth, we want to go one step further and try to figure out how we can not only do voting, but because we are doing voting, actually, you have to figure out how to do institutions in a digital way and identity in a decentralized way. And I think that could be a big threat to politicians.
We've got time for one more question.
Over there.
Yeah, I was wondering about, I like the fact that you can control your identity and anonymously manage your votes in an incomparable way. But what's to stop me from creating multiple identities?
Great question. The identity issue is one of those things that keeps me awake every night. That's why institutions are very important, because institutions define the scope of how many identities they will assign to their voters. There are institutions that have 4 voters, and it's only those 4 voters that get the keys to actually engage in the decisions that belong to these institutions. And there are other institutions that have 60,000 members, a community. We're actually working with a small island called Guernsey between the UK and France. And in this island, is really looking forward to innovate with blockchain-related technology. And it's an island with 60,000 members, and we can really try to see, there will be, a funny story about that. I met a politician once sent to me an email asking me for some documents, and I said, well, I will send them to you. And he says, send it to this address. And the address was a completely different name. I said, who is that guy? And he says, oh, I have 15 different identities. I have 15 aliases. And I'm like, wow, what does have to happen to you to just have 15 fake email accounts just because? And that's, that definitely will happen. That's why limiting the assignation, limiting the keys that an organization gives to the voters and structuring the organization the right way is very important. And to us, this is a whole new field. It's not very easy to develop decentralized applications. A lot of rules are being rewritten, but we're very excited. Meteor led us to, get to work on the user experience really very fast, very well. I'm a big fan of JavaScript, and learning a lot as we get to understand how to work with the Bitcoin blockchain. All right.
Thank you very much. All right, everybody. Thank you so much for joining us tonight, and thank you also to all of our great speakers. If you're watching online, please subscribe to be notified of new videos of Meteor's live events. You can do that by clicking on the little Meteor logo in the bottom right-hand corner of your screen. You can rewatch tonight's live stream at any time, and we'll also be posting each talk as its own video. We'll upload the talks from DevShop London and DevShop New York, our other 2 recorded events at the moment, and other events from around the world. So definitely subscribe and keep an eye out for those as well. Our next Meteor night will be Thursday, April 28th, and you can RSVP at meetup.com/meteor-sfbay. And if you're already a member, you should have an announcement in your inbox as of about 10 minutes ago. For those of you who are here in person, please help us clean up by throwing away 1 piece of trash and bringing your chair to the back corner. We still have plenty of food and drinks, so please feel free to stick around a few more minutes and hang out. Thank you, everybody, for coming, and we look forward to seeing you next time. Thanks, everybody.